Mm.
We want to talk about factorizing and 1.3, and of course it is important to know that you can write expressions as a product of their factors, and should be clear that factorizing is the opposite of expanding brackets. The moment we are talking about factorizing, we simply collect the like terms and place them outside a specific bracket, as it will be illustrated in example 6. In example 6 and part A, we are talking about factorize. The question is factorize the following expressions completely. And part A, we are having 3x plus 9. And 3x plus 9, we just have to realize that 3 is common in both terms, and therefore 3 should be outside. And inside the bracket, we are having 3x divided by 3, we have x, and then 9 divided by 3, we have a 3. And that expression has been factorized completely. If you look at part B, which has x squared minus 5x, basically every time we have x squared followed by a minus sign, or an unknown with an even power followed by a negative sign, we are very swift to think about difference of two squares. But that is also only possible when both terms have a specific or a terminating square root. But 5x has no terminating square root, so we just have to express the like terms here. So x is common in both cases. So x inside the bracket, you have x squared by x, we have x minus 5. Let's look at what is in part C. Part C, we have 8x squared minus 20x. 8x squared minus 20x. Again, this is not difference between two squares. We are not going to be quick to talk about difference between two squares, though in an advanced level we can still approach it with an idea of difference between two squares. But for now, we are simply doing factorization, whereby within the whole numbers 8 and 20, 4 is common. Within x squared and x is common, so that gets outside the bracket. Inside the bracket, we have 8 divided by 4 is 2, x squared divided by x is x. Of course, the negative 20 divided by 4 is 5, and that is it, because x divided by x is 1. So we have 4 outside the bracket, then minus, or rather, but the original question was 8x squared plus 20x, so even this one gives us plus, but there is no problem. If it was negative, then it would have been 2x minus 5. Let us look at part D. 9x squared y plus 15xy squared. We need to approach this question in the same way. Identify within the whole numbers 9 and 15 what is common. Of course, 3 is common. Within x squared and x is common. Within y and y squared, y is common, and that gets outside the bracket. So 9x squared y divided by 3x y. Of course, 9 divided by 3 is 3. X squared divided by x is x, and y divided by y is 1. Plus, because of there's a negative, a positive sign here, 15 divided by 3 is 5. Then x divided by x is 1, so there's no need of writing 1. Y squared divided by y is y, and that is a factorized version of the original expression. Part E, we have 3x squared minus 9xy. 3x squared minus 9xy. Again, the same approach. Within the whole numbers 3 and 9, 3 is common. X squared, x is common. And y is not common because it doesn't appear in both terms. So 3x get outside the bracket. 3x squared divided by 3x, we have x. 9xy divided by 3x. First of all, 9 divided by 3, we have a negative 3 because we had negative 9. And x divided by x is 1. Y divided by 1 is y. Is just y. Because the fact that we have no y here, in place of y, we can assume that we are having 1 such that y divided by 1 is y. And that is the final factorized expression. All right.